Good morning to one and all. In previous video we discussed about class C chopper circuit. In this video we are going to discuss about other types of choppers. I think we already know that choppers are mainly classified into two types. Those are step down chopper and step up chopper. This classification is depending upon the input voltage and output voltage. Now depending upon the type of the computation using choppers further classified into four types. Other types of choppers, that is depending upon the type of the commutation. Those are mainly classified into four types. First one is DC Jones chopper, Morgan's chopper, oscillation chopper and AC chopper. In first three choppers, the type of the commutation we are using is class D commutation. That is nothing but forced commutation. If we consider fourth one, that is AC choppers, it is a chopper which converts fixed AC voltage to variable AC voltage. In this we are going to use the natural commutation or line commutation. Working principle of first three choppers, that is DC Jones chopper, Morgan's chopper and oscillation chopper, is almost same. Now we can go for working of DC Jones chopper. First go for introduction of DC Jones chopper. Okay, we already know chopper is nothing but it is a circuit which converts fixed DC voltage to variable DC voltage. DC Jones chopper also same thing. It is a circuit which converts fixed DC voltage to variable DC voltage, but in this we are using the class D commutation. Means the working of DC Jones chopper is depends upon the class D commutation. Here commutation is nothing but the process of turning off the main thyristor or thyristor. Okay, in later videos we are going to discuss about types of commutations. Okay, in this DC Jones chopper we are going to use the auto transformer instead of inductor. In class D commutation we are going to use the inductor, but in DC Jones chopper we are going to use the auto transformer. Why we are going to use auto transformer is nothing but by using auto transformer we can overcome the commutation failure of main thyristor T1. That is the main drawback in class D commutation. In class D commutation we are using the inductor, so there is a chance of commutation failure of main thyristor T1. That is the introduction of DC Jones chopper. Now go for circuit description of DC Jones chopper. DC Jones chopper mainly consists of two thyristors, that is T1 and T2, T1 and T2, two diodes D1 and D2, capacitor C, auto transformer, load, and this entire circuit is supplied by a constant DC voltage source. Now consider the circuit diagram, and this is the circuit diagram of DC Jones chopper. It consists of two thyristors, that is T1, T2, two diodes D1, D2, capacitor, that is C, auto transformer, which is having here L, L1, L2, load, and this entire circuit is supplied by a constant DC voltage source VDC. Now go for working. Working is very simple. That is, by using the voltage across capacitor, we are going to turn off the thyristor T1. By turning off the thyristor T1, we are going to get the variable DC voltage. Please concentrate on working. Okay, this is the first case of working of DC Jones chopper, and this is the circuit diagram. Here initially VDC voltage source is applied to the circuit diagram. That is, the positive polarity of VDC is connected to anode of T1, anode of T2 and cathode of D1 through capacitor C. So thyristors T1, T2 are in forward blocking mode, which are act as a open circuit before giving the gating pulses to T1 and T2. And diode D1 is in reverse bias, which is act as a open circuit, and similarly the negative polarity is connected to anode of diode D2. So D2 also in reverse bias, which is act as a open circuit. That is the initial state of the thyristors and diode before applying the gating pulses. Now initially consider we are going to apply the gating pulse to thyristor T2. Thyristor T2. So thyristor T2 comes from forward blocking mode to forward conducting mode, and it is act as a short circuit. This is a circuit diagram by applying the gating pulse to thyristor T2. By applying gating pulse to thyristor T2, it acts as a short circuit and allows the flowing of current from VDC plus to VDC minus in the path VDC plus capacitor, thyristor T2, L, L2, load and VDC minus, that is nothing but in this path. And here capacitor starts charging with upper plate as positive and lower plate as negative, means same amount of input voltage is going to appear across the capacitor C. So the voltage across capacitor is VDC, and same amount of voltage is appears across the load also, that is V0 is equal to plus VDC. Here thyristor T1 is connected in parallel to the capacitor, so same amount of voltage across capacitor is going to appear across the voltage across thyristor, that is VT1 is equal to plus VDC. In first case, capacitor charges with upper plate as positive and lower plate as negative. This lower plate is connected to anode of thyristor T2. So thyristor T2 comes into off state and act as a open circuit. Similarly, this negative polarity is connected to cathode of diode D1. So diode D1 comes into forward bias and it acts as a short circuit, and this negative polarity of source is connected to anode of diode D2. So diode D2 is in reverse bias and which is act as a open circuit. In this case, we are going to give the gating pulse to thyristor T1 for making the capacitor is to discharge. By applying the gating pulse to thyristor T1 comes from forward blocking mode to forward conducting mode and it acts as a short circuit. This is the circuit diagram by applying the gating pulse to thyristor T1. By applying gating pulse to thyristor T1, capacitor starts discharging from C plus to C minus in the path C plus thyristor T1, L, L1, diode D1 and C minus, that is in this path. Means the capacitor C starts decreasing from VDC plus to VDC minus, that is nothing but discharging of this capacitor, and here thyristor T1 act as a short circuit, so the voltage across thyristor T1 becomes 0, and here the voltage across load is negligible or 0. Why? Because compared to this diode, the resistance of this load is high, so it opposes the flowing of current through load. It allows the flowing of current through diode, so the voltage across load is negligible, that is nothing but V0 is equal to 0. After complete discharging of capacitor changes its polarity, that is positive polarity becomes negative and negative polarity becomes positive, and here negative polarity is connected to thyristor T1 anode, so T1 is in off state which is act as a open circuit, and similarly the negative of source is connected to anode of D2, so D2 is in reverse bias which is act as a open circuit, and the positive plate of capacitor is connected to cathode of diode D1, so diode D1 is also in reverse bias which is act as a open circuit. Now this positive plate is connected to thyristor T2, so thyristor T2 is in forward blocking mode. Now we are going to apply the gating pulse to thyristor T2. By applying the gating pulse to thyristor T2 comes from forward blocking mode to forward conducting mode, and it acts as a short circuit. This is the circuit diagram after computation of thyristor T1. In this case, capacitor changes its polarity, that is positive plate as negative and negative plate as positive. Again we are going to apply the gating pulse to thyristor T2. By applying the gating pulse to thyristor T2, it acts as a short circuit and it allows the flowing of current from VDC plus to VDC minus through the path VDC plus capacitor thyristor T2 L L2 load and VDC minus, that is nothing but in this path. In this case, the total input voltage appears across the capacitor but as a negative. Why? Because the polarities of capacitor is negative and positive. So total amount of input voltage appears across the capacitor but as a negative. Here thyristor T1 acts as a open circuit, means the total amount of voltage across the capacitor is appears across the thyristor T1. That is same amount minus VDC is appears across the thyristor T1. VT1 is equal to minus VDC, and same amount of capacitor voltage is going to appears across the load V0. That is nothing but V0 is equal to minus VDC, and same process going to repeats for the remaining cycles. Now by using above discussion, we are going to draw the waveforms for DC Jones chopper. In this case we are not going to plot the waveform for output voltage V0. We are going to plot the waveforms for voltage across capacitor as well as voltage across main thyristor T1. Okay, these are the waveforms for DC Jones chopper. Here VDC is the input voltage which is having constant magnitude, and these are the gating pulses we are going to apply to the thyristors. We are going to plot the voltage across capacitor as well as voltage across main thyristor VT1. Initially we are going to apply the gating pulse to thyristor T2, that is IZ2 is going to apply for thyristor T2. By applying gating pulse to T2, we are going to get the same amount of voltage. Input voltage is appears across the voltage across capacitor, that is T2 is in on state, and same amount of input voltage is appears across the capacitor. And here thyristor T1 is open circuit, so same amount of voltage across capacitor is going to appear across the voltage across thyristor T1. Okay, after complete charging of this capacitor, we are going to apply the gating pulse to thyristor T1. By applying the gating pulse to thyristor T1, the voltage across capacitor means capacitor starts discharging from VDC plus VDC to here minus VDC, and in this case thyristor T1 is in on state, means the voltage across thyristor T1 is 0 volts. After complete discharging of this capacitor changes its polarities, and we are going to apply the gating pulse to again thyristor T2. By applying the gating pulse to thyristor T2, same amount of input voltage is going to appear across the capacitor but as a negative, that is minus VDC voltage is going to appear across the capacitor, and here thyristor T1 is connected across the capacitor, so same amount of voltage is going to appear across the thyristor T1, that is the voltage across thyristor T1 is minus VDC. Again after complete charging of capacitor, again we are going to apply the gating pulse to thyristor T1, and same process going to repeat for the remaining cycles. In next video, we are going to discuss about AC choppers. We are not going to discuss about Morgan's chopper and oscillation chopper. Why? Because the working principle of DC Jones chopper, Morgan's chopper and oscillation chopper is same. So we are going to consider the working of AC choppers. Thank you.